All right, we have made it to section 0.5. This one's on inverse functions and logarithms. So in this section and set of videos, we will learn about one-to-one functions, inverses, how to find inverses, logarithmic functions, properties of logs, and their applications. So we begin in this video with 0.5.1 and one-to-one functions. Just one vocabulary. It's the title of the section, what's a one-to-one function, and no theorems or rules here. So we begin with a recap of the idea of a function. It's a rule that assigns a single value in its range to each point in its domain. And that's a little of a backwards moving definition. So if we think about a function, we have a domain, we have a range, and a function takes every element from the domain and maps it to just one and only one element from the range. Okay, so we have this idea that some functions assign the same output to more than one input. For instance, f of x is x squared, and other functions never output a given value more than once, such as x cubed. So let's take a look at Desmos and see the difference between those two functions. So x squared and x cubed. Let's take a look first at x squared. So for this function, the domain value of 1 is mapped to 1. But also the domain value of -1 is mapped to 1 as well. So the element from the range, 1, has been used twice. The same with the element from the range, 4. It is mapped to 2, but 4 is also mapped to -2. For the function x cubed, that does not occur. 1 goes with 1, but -1 goes with -1. And 8 is the range element that goes with 2 from the domain, and -8 is the element that goes with -2 from the range. So we never have any value from the range used more than once. So those functions are the particular ones that we're going to be looking at in this section. So if each output value is associated with exactly one input value, that function is said to be one-to-one. One range item per one domain item, one domain item per one range item. So here's our formal definition. A function f of x is one-to-one on a domain D if for every y value that is different from another y value. So what we're saying here, for every unique y value, there is a unique x value. This is more just a formal way of notating that. So for every unique y value, there's a unique, I should have said x value there. Graphically, a one-to-one function will do something called passing the horizontal line test. So we know about the vertical line test from function study. This is a horizontal line test. So let's look at the graph again of y equals x squared and y equals x cubed. So if we start passing through horizontal lines on the function x squared, you'll notice that we pass through this function multiple times for each of these horizontal lines. And as we said in the last slide, x squared is not a one-to-one function because it assigns range values more than once. So this one fails the horizontal line test, and it is not one-to-one. But for x cubed, every horizontal line we pass through only touches the function at one point, and this one passes the horizontal line test, and it is 1, 2, 1. So let's use that information here in the first example. Determine whether the functions are one to 1. So first we have f of x is the absolute value of x, and then we have g of x is the square root of x. So let's head over to Desmos and check those out. Here's absolute value of x, and we can see that if we were to run horizontal lines through this, we would have multiple touches, much like we did on x squared. This one fails, and it is not a one-to-one function. But for y equals the square root of x, we do have a function that passes the horizontal line test, so that one is one-to-one. So we can, for our notes, sketch those functions here so that we have them down and here. So this function, let's try that in blue. This function here, and the V-shaped for absolute value. This one fails the horizontal line test. This one passes the horizontal line test. And so we can say not one-to-one. And here we're going to say one-to-one. All right, hope that video was good for one-to-ones. I'll see you back in video 2.